everyone. Welcome back to my math teaching channel online. Today, I want to show you one example in the application of derivative and how useful it is for the decision making of our sale and the price and the profit. So let's get into the question and see how we can use calculator to deal with this kind of problem in economics. So let me read the question to you. A chain of stores has been selling a line of cameras for $50 each and has been average sale of 8,000 cameras a month. They decide to increase the price, but their market research indicates that for each dollar increase in price, the sale will fall by 100. Find a demand function. Find the price will maximize the revenue. Okay, so let's summarize what the question tells us and what the question asks us. So they say that there's a price for each camera. So given the price for each camera is $50 each. And how many of sale they make? So the number of sale is 8,000 camera per month. So that's what they tell us. What else do they say? They say that the seller want to increase the price. So increase price. So the price will be increased, will be added into it. But unfortunately, like the balancing out, right? So if you raise the price, usually the number of customer will going down, because if it's cheap, they will buy more. If it's higher, it's more expensive, they will buy less. So one going up, one going down, right? So that's the balance of life. So let's see. So they said that for each dollar increase in price, right? So for $1 increase in price, unfortunately, minus 100 number of sale, right? Minus a number of sale will be decreasing. So one is increased, one is decreasing. So for each dollar increase in the price, unfortunately, there will be less sale by 100 cameras, right? So instead of selling 8,000 cameras, now they only can sell 7,900 cameras if they raise the price by $51, right? So that's the idea. So let's get into the answer here. They say find a demand function. So what is a demand function? A demand function is the price function, right? Px. So let's get into that. So how we make a solution for, how do we make a demand function? Now there's a way of find demand by an easy way, which is we learned in Math 10 already. We can draw a map and then we find the slope of the line and we can put in the equation. But I don't want to show you that method. Let's get into in the thinking process how we're going to establish our Px function. So Px is the price function. And before we do that, we have to establish some kind of variable, right? Now we know that our price, right? The new price will be equal the old price, right? The old price adding with the increasing, right? For each camera, right? So our new price will be equal, basically will be equal $50, adding with how much? For $1 increase in price, $1 increase in price, there is 100 camera loss, right? Camera loss. So actually, the dollar of increasing is not $1 per camera, right? But it's $1 per what? 100 camera, right? So therefore, the rate of increasing will be equal 1 divided by 100, because it's 1 for 100. It's not 1 for per camera, right? It's not $1 increase per camera, but it's $1 increase per every $100. So the rate of increasing for each camera is just 1 out of 100, right? $1 out of 100. So that's a rate of increasing. So that is the new price, right? Because for each camera, they increase by $1. By 100 camera, they increase by $1. So to find for one camera how much it increased, it had to be 1 over 100 camera, right? Now this one will time with, because this is the amount of increasing, right? Of the rate of increasing of each camera. But this rate of increasing have to multiply with the number of camera, right? Because if we sell by 2,000 camera or 3,000 camera, for each of them, the rate of increasing is 1 out of 100. Then will be timed with 1,000 camera if the number of sale is 1,000, right? Or if the number of sale is 200, will be multiplied with 200 of them, right? Because this is the rate of increasing for one of them. But the number of camera is not just 1, right? It will be more than that. So we multiply with the number of cameras. Now, how do we multiply with number of camera? We know that the number of camera is supposed to be 8,000 if we sell $50 instead of adding with a little thing in here, right? So we don't know what inside here, but we can make a decision that let X be the let X be the decreasing, the number of decreasing, the number of camera decreasing, the number of camera decreasing, right? Then the new number of camera will be, our price will be equal $50 add with the rate of increasing for each camera time with 8,000 minus X, because we name X be the number of camera decreasing. So if X is the number of camera decreasing is 1,000, then the number of camera here will be 7,000 instead of 8,000. Or maybe X will be 2,000, then the number of cell camera here will be 6,000. So our price will be based on the increasing rise, the rate of one of them times with number of cell here we can sell, right? So that is the price, the demand function. Now let's summarize this demand function. So 50 add with 1,000, 1 over 100 times with 8,000 is what? I'm gonna cancel this, cancel that, cancel this, cancel that. So it equals 80, right? Minus this time that is 1 over 100x. Simplify it, it will be equal 130, subtract 1 over 100x. So that is the demand function, the price. Now, to find the price that will maximize the revenue, to find the price that will maximize the revenue, we can base on the demand function, the price function, to find the revenue, right? Remember the formula I told you before, revenue will be equal Px, the price, time with X, right? X is the number of sales. So here in this question, we will say, let X be the new number of sales, the new number of sales, right? And the new number of sales, we don't know. It could be 6,000, could be 7,000, or whatever, how many cameras going down, right? So let X be the new number of sales, but we know that it will be going down, it's not going to be going up, because they said that if we raise the rate by $1, then 100 camera will going down, right? So we know that the X here is the number of sales, but it will be less than 8,000. It's not going to be 8,000, right? So our price function is what? We substitute our price function here by 130 minus 1 over 100x time with all of this, with time with the number of cell, the new cell, we call x. So now our revenue function will become 130x if we distribute this in here, right, in this bracket, minus x squared over 100. So that is our revenue function. Now, how do we maximize the revenue function? To maximize the revenue function, to maximize it, we have to take the derivative, right? Take the derivative of this and set it equal 0. Remember, when we take the derivative, we find the maximum or minimum. Now this function is a parabola and it goes down because the negative, right? So you know this is the maximum revenue, right? Because the parabola going down. This is a indicate that we learned math 10 already, right? So now, so take the derivative of this will be equal 130, right? Minus, so minus, is 1 over 100. We bring down the 2, right? And we change it become x. So our new revenue function will be equal 130 x. No, 130 minus 2 cancel with that is minus 1 over 50 x. Okay, so that's a derivative of revenue. So now, how do we find out the maximized revenue? We find out by set up the R prime of x equal 0, right? So this function, sorry, R prime of x, this function so let's say this is x will be equal to 0. So now let's solve for x. So I am going to transfer this over. So I will have minus x over 50 equal minus 130. Now they both minus, so I'm going to change both positive, right? Left side and right side. So now solve for x. X will be kicked up. So x equal 130 times 50. And what is 130 times 50? 130 times 50, 20, 6,500. So the X here is the number of cell, which is 6,500 camera. So the new cell is actually is no longer 8,000 camera, but it's 6,500 cameras. So this will maximize our revenue. So our revenue, right? Maximize revenue, we say maximize revenue will be equal. Now, how many camera is so 6,500 camera will be sell, and so that how many decreasing, how many number of camera decreasing? 5,000 minus 6,500 equal 1,500, right? And so we know the amount of increasing in dollar, right? Increase in dollar will be what? 1,500 divided by 100, right? For each 100 camera, then $1 increase. So we have 1,500 divided by 100, which is $15 increasing, right? In price. So the new price is what? $50 at 15, which is $65 for each camera. So that's our new price. And this new price, with this new price, we will earn the maximum revenue if we can sell 6,500 cameras. So if we want to find the maximum revenue, all what you do is, if you want to find out the number, right? So if you want to find out the number, all what you do is using $65 times with 6,500 camera we sell for the new project, right? So how much is that? Let's calculate. So our maximum revenue will be 65 times 600, it will be $422,500. So that's the new revenue. Okay. Now compare with own revenue is what? Own revenue, we have $50 if we don't increase the price. And we can sell 8,000 camera. So that will give us 400,000. So obviously, even though if we raise the price by $15, right, by $65 for each, and we sell less, we only sell 6,500 instead of 8,000 camera, we still earn better revenue. Our new revenue is 422,000, bigger than this, right? So bigger than this one, so it raised by $22,500 revenue. So if we know how to do math like this, we can make our decision. We say, oh, even though for each dollar we raise, we sell less 100 cameras, but we still make better. At the end, with the new revenue, we only sell 6,500 camera, but we still earn 422,000. Whereas if we keep the price at $50 and we can sell 8,000 per month, our monthly revenue only 400,000. So obviously, it's easy to make decision, something like that, right? So, okay. So sorry, I'm going to show you again, right? I say that after we calculate the price increasing, we know the revenue, we find out if we set up our revenue to maximize revenue, we got number of equal 6,500 camera. So we know that we have the number of camera have decreasing by 1,500 instead of 8,000. Now it's just 6,500 in sale, and it means decrease by 1,500. Now for 100 camera decrease, $1 raise. So if we use this, divide by 100, we got $15 raising, right? So $15 adding to the own price equal $65 each camera. Now we want to find out is that benefit 65 times with 6,500 camera, we got 422,500 revenue. Whereas if we keep the own price at $50 times with 8,000, we got only 400,000 revenue. So yes, it's a good decision made. So I show you how we use calculus to make decision on sale. I don't know if you like it or not, but I found it interesting, right? Okay, now I want to, before I end this video, I want to show you another way of thinking, right? So that you can get going with your exercise and I don't have to show you another video about this anymore. So I'm going to show you how we answer the question B if we don't use a demand, we don't answer find a demand function. But let's say if this question ignore the first one, only ask you find the price will maximize the revenue. So you can find the revenue function right at start. And the revenue is equal new price times with new number of sale. New number of sale. And we're going to say let X. So this is another way of solving the question B, which I found a lot easier, okay? Let X be the price increase in dollar. So now maybe we can increase $10 or maybe $20 or maybe $60, right? We don't know. So we say let X be the price increase in dollar. So our revenue will be equal the own price, which is 50, adding with the X price of increasing, right? Maybe we increase by $10 or maybe $11, whatever it is we put in here. So that's the new price, times with the new sale. And we know that our new sale will be 8,000 camera, subtract. For every $1 increasing, we decrease by 100 camera. So let's say if we increase by $2, will be 2 times 100 camera, right? If we increase by $3, then it will decrease by 3 times 100. So if we increase by X dollar, it will decrease by X times with 100, right? And that will be equal 100X. So 8,000 minus 100X. Does that make sense to you? I hope, right? If we increase by $1, we go down by 100 camera. We do 2, we go down by 200 camera. By 3, we go down by 300. And how do you get 300? 3 times 100, 2 times 100. So X, the number of cell decreasing, will be X times 100. So that's how we get this equation. So let's find out our revenue function. So our revenue function, now I think this is a lot easier to think, right? By using, but because we stuck with the question A, we have to find the demand function. So we have to go through the more difficult process. But if the question just asks you this question B, then it's easy, you can just find the revenue right there, the revenue function. By 50 adding with X dollar, this is a new price, time with the new sale. The new sale is 8,000 minus 100X. So now let's simplify this. This will give us 400,000 times with minus 5,000 X, adding with 8,000 X and minus 100 X squared. So now our revenue, let's simplify this, will be 3,000 X, right? Minus 5,000 at 8,000, 3,000 X minus 100 X squared, adding with 400,000. to maximize revenue, we take derivative of it, and this number become 3,000, and this number become minus 200x, and this number becomes 0, right? So now let's set this equal 0 and solve for the maximized revenue, which is 3,000 equal 200x. Divide both sides by 200. We got x equal how much? 50. So now we say that let x be the price increasing in dollar. So yes, the price we should increase is $15 increasing. And our new price will be 50 and 15 equals $65. So we get the same answer by using this method. But using this method I found it more complicated. And that's why I want to show you there is another way of solving the equation, which is a lot easier if we don't get stuck with the first question. But because we do this way, because we have to find a demand function first. Then after we find demand function, then we find the revenue using our demand function, right? In this way. In this way, if we don't have the first question, we can just go ahead and do like this. So I show you both way, and I hope that you enjoy and understand the concept. It's a little bit high level of thinking, right? But you have to think logically, right? So then after you understand the concept, you can do the exercise I upload in the files, similar question like this. So that's why I want to show you two way of handling this solution. We can solve it in both way. And the good thing in math that either way you get the same answer. You see that we get $65 here, the same way we get $65 in this way as well. So I hope you enjoy my teaching video today about derivative in economics. Stay tuned for the next video, more interesting stuff. And probably I will, in the next video, I will show you about the derivative of trigonometric function, and then the derivative of logarithmic function, and one more chapter to go, which is extreme value. I think that's it. The chapter 6 will be the derivative of trigonometric function and derivative of logarithmic function and their application as well. And in this course, I show you a lot of word problems, how to apply the calculus derivative to solve the word problems. And so actually this introduction to calculus have two components. First course and the second course. Now in the first course, so I split it, become a mini courses, right? So the first course will deal with derivative, and the second course will deal with antiderivative integration. And we learn that in the second course. And that will be cover the whole intensive course that the student learn in 1 year. I am making it, teaching you each day and each video, and I shorten it in, like in 3 months or something. So I think this course is very beneficial to your learning, to be honest, if you pursue it to the level of calculus in university. It helps you a lot to give you a lot of concept to deal with, to understand what is calculus, what is the derivative, the rate of change. You never learn it in Math 12. So if you encounter a work heavy load in university and you don't have a background of this, I believe that you will find challenging, you will find yourself challenging. Okay, So I hope that you will find this course is very useful to you, and I hope you will register to my course when I publish it. So bye for now and see you in the next video. Thank you for watching. Now give me a thumb up if you like my hard working, and just hit like and please subscribe to my video. Thank you.